Guys, guys, if you are ready, please confirm. Okay, please speak up.
Yeah, I'm ready.
Shall I
Yeah.
continue?
Okay. Yeah, we can continue. Yeah, we
Okay.
get two
Okay.
confirmations. Yeah.
So first, we shall start with the very basic breadboard. First you want to select here this components basic to all. Okay. Then only all the components will be visible. So select the breadboard first. You can slide down and select breadboard here. Breadboard small. There are three types. You can select breadboard first. Just drag it to the screen. So this is our breadboard. And just an intro, breadboard has two rails on the both side, negative and positive rails. This means here negative, you can see that there is a line, which means all that line has the same connection, and the positive means all that side has the same connection. Here we can see the vertical all holes has the same connection, which means when I connect here a wire and here a wire, these two has the same connection. Okay, is this much clear?
So all
Yeah,
the
yeah.
vertical holes are having all the horizontal holes are having a single wire connection, right, beneath the breadboard.
Yeah.
Okay.
I will try one more. So we
And
can
one more
select that.
thing, if anybody faces any problems with this Tinkercad on Windows, just let us know. Okay. Thank you.
Okay. So just explaining one more time with very basics. Okay. Yeah. This is one LED, and you can know this is the cathode. So we can connect it to the negative. We can change this wire color to black as the negative is black. Okay. And if this we take wire from here also, this two has the same connection, which I mean. I hope this and everyone understood. Okay.
Yeah, yeah.
Yeah, this rail that means okay. Just let a minute. This all the rails has the same connection, or all the rails are connected into a single wire. So from anywhere we can pull out the one wire and continue this wiring as from here. Okay.
So they are gonna have same potential at all the points
Yeah, yeah,
vertically,
yeah,
right? Yeah.
yeah. Basically, below the breadboard, there is a straight one silver lining below the breadboard, which has means all the holes are connected to that lining. One straight line is there. Okay, one straight metal in between in down of the breadboard.
Yeah,
Okay.
yeah, yeah.
Maybe wait one more minute. I will share one more thing. Bread. Can you see guys this guy window?
Yeah,
Hello.
yeah. We can. Yeah.
Yeah, what I mentioned, there is a this is the breadboard front side and this is the tier of cider. Okay,
Ah, yeah.
so you can see that this is a line. So there is a metal which has a straight line, which means oh sorry, okay, which means all that holes are connected to this metal only. Is that understood? Okay,
Yeah, it's clear now. Yeah.
yeah. For the vertical side, you can see there is a vertical metal below placed below. So
Yeah.
all
Okay.
that points has the same what we can
Potential.
say same
Potential.
potential or the same connection.
Yeah. Okay.
So we can pull out from one hole or next hole, which means it is the continuation of that wire. Okay,
Yeah.
is there any other explanation necessary?
Yeah. I think that would do. Yeah. We can
Yeah,
continue with the circuit.
so we can come back. So I will start with one of the basic, just one LED. Okay. Oh, sorry, we can start with a bulb first. because LED requires a resistor more. Yeah, this is a bulb. And next one, we need a potential. So we can use function our power supply. Just a drag here. And by selecting this power supply, we can see here, we can choose any name for that power supply. Let it be V in. And the voltage, whatever the voltage we need, 10 or 5 as per our requirement, currently not need to mention. Okay. So first connect this positive to our positive side of the breadboard and change the wire color red. Okay. Next, negative to any of the negative. You can choose anything negative and change the color to black. So one more thing to mention, since we are assembling many more components in the breadboard, we need to use both this rail, first rail, top rail and down rail. So we can easily take connections from positive and negative to our components easily. So positive to here, just positive here, red, then negative to negative here. Okay. So basically what happens means this function this power supply will produce a 5 volt and will come to here, and we also connect this to here also, so that all this top and bottom has the same potential. I hope this is much clear. Okay,
Yeah, it's clear. Yeah,
what about others? Okay,
guys, you can speak up if you have any doubts.
Yeah, that's
No
fine.
idea
Still
doubts?
here.
Okay,
Yeah, it seems fine. Yeah.
yeah. So as our basic thing, we need to blue this bulb. So we can connect, as bulb has no polarity, but LED has polarity. Bulb is not a semiconductor, so it has no polarity. We can connect either of the terminal to positive or negative. So and choosing this connection, all these points has the same potential, so we can connect anywhere as you like, and change the color, because you need to change the color, otherwise it will be very much difficult to understand the wire connections all. So all this is completed, or you can connect these two wires to bottom rails or the top rails as you like. So click on the start simulation. So you can see that 5 volt is supplying, and it is 104 milliampere is flowing through this bulb, and our bulb is blue. Okay, is this much clear?
Yeah.
Yeah, it worked for me. Yeah.
Yeah, this is our first connection, this basic connection I think. So everyone can try this. Okay, so next, I hope everyone understood this breadboard basics. Okay,
If you have any doubts regarding what we spoke up to now, you can raise your hand or you can chat. Put your questions in the chat.
is there any other doubt? I will explain one more thing. You can connect this terminal.
This is a highly informal meeting. You can speak up any way you
Yeah,
want. No
guys.
problem at
Yeah,
all.
this is an informal meeting. Okay, don't find it to
Yeah.
be so formal.
Yeah, okay.
Yeah, yeah.
Yeah, we can connect this terminal to this one vertical line. I am just explaining one more thing. A vertical line, as one is positive, we can mention this as black. And as I earlier told, this all vertical points has the same connection, which means this wiring ends here. We can continue this wiring from either of these 4 possibilities. So I am continuing this wire from, so which means top that it is a continuing wire. So we can connect this to here. This connection is also the same. So we can start simulation. You can see the bulb is blown. Okay, which means a positive is connected to here, negative to here. As a continuation, this all points has the same potential, so connected to the negative, which means the circuit is completed. This is one more possibility. And next possibility, you can connect this terminal to positive anywhere on the bottom terminal and change the color to red and simulate, which is also the same connection. So I explained all the basics of the breadboard. Okay.
Yeah, we can move on, I guess.
Okay. So next I will introduce one switch to our breadboard. So there are many type of switches available here. Push button switch. I will choose the slide switch. Okay. So we can name anything. The first terminal or the leftmost terminal should be grounded to positive, and the middle terminal should be grounded to negative of the side switch. Okay. Then our connection should be made from, it is yeah, you can, okay, it is all for all the switches, it should be followed. Okay.
Actually, Elias, would it matter if we do it the other way? Like if we put the leftmost wire, rightmost wire to be on the positive side and the leftmost to be on the.
Okay, actually this is a three-way switch. If you connect anyway, desired output will be made, but it is more desirable in this manner, because
Okay.
when we turn on the switch means we'll get the output. It is,
Okay, yeah.
it is not a two-way switch, it is a three-way switch.
Three-way switch, yeah.
Okay. Okay,
Yeah.
Since we are only getting three-way switch from this component side, we are going through this switch. Okay, slide switch. So in the slide switch, it is more desirable to wire in this manner for all the switches, negative, positive to this side and negative to, sorry, negative to this. Okay, and we can take the output from first. Okay, sorry, from the left terminal. So you can draw this wire to anywhere and connect to this point and take the connection of the bulb to this point. As I earlier mentioned, all these points has the same connection, and start simulation. You can see that our switch is off. When we turn on the switch, the bulb is on. When we turn off the switch, the bulb is off. Okay, I hope everyone understood this. Okay. Any more?
Can you tell this once again? Like, can you explain once more?
Yeah. Okay.
From
First, we start from the power supply. And
you can skip that part about bringing in the switch.
Okay.
From bringing in the switch, yeah.
Yeah. Okay. Bringing the switch. So just slide one switch, and the first terminal one. Here, you can see that common is there. When we mouse over the terminal, you can see that common connection.
Okay.
Either connect. If we connect positive to here means this will work. If we can see that when we slide to this right of the slide switch, bulb is on. And as Dan told, if we connect to this positive to here means we can
like the reverse of the normal switches that we use at homes. That will happen. The reverse. When we put on off mode, the light will turn on, and when we put on the on mode, the light will turn off. Like, but usually we use in that way. Then we have to connect like this. That's the thing.
When you take the switch, it is more desirable to connect first terminal 1 to the positive and common to, anyway, common itself. Common means negative. Okay, as we talking in the electronics, common means negative. Okay, so positive to first terminal to positive and take the output from terminal 1 itself.
Okay, we have a doubt now. Can you see the chat section?
Yeah. Okay.
Like he is asking if we can connect the third terminal to light the bulb.
Third terminal, I am not sure about that. Just third terminal we can choose. Okay, you can connect this and test. No problem at all. As we switch on the switch, there is nothing happening. Okay. Just to go with this design, I think it is more good. I think just to take the output from the terminal 1 itself. Okay. So start simulation. Turn on the switch, then the output will be there. I hope everyone understood this. Okay.
Elias, one more doubt.
Yeah.
what when I tried turning on the switch, I couldn't, because when I slide the switch, the switch moves along. The wall of the 3 terminal
No,
moves
no.
to another.
Click on the start simulation first,
Oh,
then
okay,
turn on the
yeah.
switch. Okay.
Okay, yeah. Now got it. Yeah.
Yeah. Okay. Any other doubt? Okay. Can I continue?
Yes, please. Yeah.
Yeah.
Let's give them a minute, because if they are typing, then it might take some time.
Yeah.
Okay.
You can also comment this switch by dragging this one. You can see, and by seeing that you can write any of the nodes here, like switch to switch for turning on fan. Okay, just for getting an idea. Okay, this is the commenting. You can comment anywhere. Okay.
Yeah. Okay, Elias. I think we can continue. Yeah.
Okay. Okay. Next, we can see one more thing. So I explained that breadboard basics and the bulb side. Next, we can see the IC side.
Okay, Elias.
Yeah.
Can you give a briefing on IC, if it's possible?
Yeah. Okay. There are lot of ICs available now. Just like timer IC, there here we can see 5555, 555 ICs there. OP amp ICs there. Many ICs are available. As per our requirement, we should select the IC, and inside IC also, depending upon the output current, input current, there are lots of varieties are there. So in this Tinkercad, we should there are only limited number of ICs here. So for NAND IC, this is only available. Quad NAND. Quad means there are 4 NAND gates inside that single IC. That means quad. Okay. I hope everyone understood this. Yeah, quad IC. So this IC only available. So we can use this IC. Nothing need to know more about that IC. Just understand that NAND, that this IC can serve the need of NAND gate. Okay.
Yeah. Okay.
So by just leave this whole thing and look at all NAND gate only. Okay.
If you
This
need to
IC,
know more about a particular IC, you can Google them.
yeah,
Okay.
yeah, you can Google it. You can Google NAND gate IC data sheet. There are a lot of things available here, but now
Yeah.
much of the things won't be understood now. Okay.
Yeah.
So we can draw whatever the IC required here. So we can see a
Actually,
no.
Elias, can I break you 1 minute? Yeah.
Yeah, yeah.
So just now I called ma'am, Suja ma'am, and I asked about IC, about what they will be doing about the IC part. So
Yeah.
when I asked her, she told us that towards the end of the course, like towards the end part of this DCS course, ma'am will be teaching about IC. We don't have ICs right now, but ma'am said she will be teaching about them towards the end of the course. So what she said today in the class was just for a familiarization, nothing. If you like, it's preferable that you go through some of the ICs, some basic workings and principles of some
Yeah,
basic
yeah,
ICs.
there are a
Yeah.
lot of ICs, but
Yeah.
nowadays we are using at mega ICs, programmable ICs, PIC IC. There are a lot of IC. You can know about Arduino all thing. We can program our requirement into that, burn into that IC, so that IC will serve us our need. That leave it that. So only we need is
Yeah. Okay.
NAND or basic ICs. Okay.
Yeah. Yeah.
So first we can use any from the, we can start with the basics. So NAND IC.
Okay, Elias, one more doubt. So,
Yeah.
like this, are ICs like NAND and NOR and OR gates and gates? Are they all ICs? Like, are they all parts of ICs, or they are supposed to be logic gates, right? And
Okay,
ICs
okay,
are.
okay, okay. Let one stopping the sharing. I'll share one more time. Okay, okay. Okay. Yeah. We can see this thing presentation.
Yeah, yeah, I can. Yeah,
Yeah.
we can see.
Basically this not IC. So not IC is in Tinkercad. It will looks like hex inverter. Okay.
Oh, okay.
What is inside this IC? Inside this IC, some fabrications are made.
Hmm.
So that is explained by this figure. So you can see that there is a notch here. Notch means one small hole. Small hole not, there's a cutting in front of that IC in order to locate which is the first point. what is the first pin out.
Okay. Yeah.
So you can also see in this figure, there is a notch here. Okay. There is a notch here.
Yeah. Notch. Yeah.
And there is a
I can see.
dot also here, which means this is the first pin.
Okay. Yeah.
Otherwise,
First.
you will be confused when you receive one IC, which is the first pin. We don't know.
We don't. Yeah. So it's used for counting, right? Okay.
Yeah. If nothing is mentioned, means it can be this, or this, or this.
Yeah. Any of the four corners. Yeah.
Yeah. First, but if there is a notch and point is there, we can see that clearly it is the first pin.
Yes.
Okay.
It's obvious. Yeah.
So notch and a dot I cleared. Okay. And we can see that first pin, it is a NOT gate.
Yeah. Not gate. Yeah.
So if we connect any of the wire to here input and 2 to here, it will just invert that.
Invert the signal. Yeah.
So basically there are 1, 2, 3, 6 inverters are available inside this single IC. Yeah. So it is known as the hex inverter.
Okay. So what this basically performs is a NOT function that that takes 6 inputs and 6 outputs, goes from these 6 inputs.
We can design. It is not compulsory to input 6. We can
6
use 1.
Okay. Okay.
Maximum is 6. That is okay.
Okay. So don't we have like a single NOT gate in Tinkercad to work on?
No.
Okay.
That's not possible. Okay.
Yeah. Now okay.
Okay. Then as we take any of the IC, first step is
they have already designed some presets for us to use. That's the only things that we can use. That's the problem.
Okay.
I think many of the wardrobe and IC circuit simulation software that is available. One NOT gate is available. LT space also available.
Okay. So I was also asking, like, when we go to some hardware shop and try buying these.
No, that IC only available. IC only.
Yeah.
We can purchase an IC, not a single NOT gate. Okay.
Single NOT gate is not available. Like and the basic beginner stuff can all be done with this gates itself. This IC itself. Like single gates.
One more thing I am adding. All these gates can be constructed using transistor, single BJT transistor. You can construct all these gates.
Yeah.
Not necessary. IC is not completely necessary. You can construct using BJT also.
BJT is also, yeah, okay.
If possible, I will construct one also. And okay, I'll try.
Yeah.
And you can also ask studied in the 12th. You can also 2 diodes for constructing OR gate.
Yeah. Okay. Yeah, we know that. Yeah.
It is not compulsory to take the IC, but for business we can take the IC.
ICs. Yeah. Got it. Yeah.
Got it. So I hope when we take any of the gates, and so any of the ICs, first thing is to ground the 7th pin to the ground. Ground means negative. And this VCC. VCC means power to power. Okay, positive side. This is the first job should be done when we take an IC. Okay, I hope everyone clear. Hello.
Yes.
Hello. Yeah. So, okay, everything is done. So we can see that
it's clear. It's clear.
08 is the IC I taken. That is the AND IC. Okay. And IC, we can see that there is the 4 AND gate available here. 1. So 1 and 2 are the inputs of the AND gate, and the 3 is the output of the first AND gate. Okay. So I am deleting all this.
Actually, these layouts have already been shared in the group. If you have any doubts regarding the layouts, you can see the group.
Okay. I will try with the one basic AND gate. Okay. So first one, we can try with the 2 inputs.
And one more thing, if anybody hasn't got the breadboard part right, like haven't understood it, I have already shared a link, YouTube link. You can view it. It actually explains it really good.
Okay. So we can start with the basic AND gate, which means A, B, 4 possibilities. We can try. Okay. So in order for the input A and B, there we need a switch for separate input for both A and B. So as one switch is here, I will try with the other switch. So output from here, it will be A. Is that understood?
Yeah, got it, Alias.
Okay.
Yeah.
So we can choose also one more switch also. Slide switch. So let it be the output of B. We can comment this for easy identify. A. We can choose comment here. This one. Okay. Yeah. So
Alias, there is one more doubt. How can we get the ICs from the component part? Like, what do we search there in the tab there, the right side tab?
not searching. I just go
It
down.
is present under the logic section.
Yeah.
Then it's
Yes.
present under the logic section.
Logic. Okay, logic.
Just go through this. You can
Like,
just yeah.
Look, Dan, you can change that components from all to logic. If you change, then you can see all
Components.
these ICs. You can
Oh,
change
okay.
that
Yeah.
from all
I'll
to
do that.
logic. Then you can
Okay, yeah.
see all the
Yeah,
ICs.
I did that. Did that. Yes,
Or
yes,
just
yeah.
search the ICs. If you
Okay.
know the number, just search. Or
Okay,
just
okay,
go
got
down
it.
through.
Got
Okay.
it. Yeah, got it.
So okay, we take the two slide switches. Let me wire from the starting. If anyone doesn't know. Okay. So we took one IC, one bulb, and two slide switches, and we are trying AND gate, basic AND gate. And basic AND gate has two inputs. We can see that two inputs, there are three and one output. Okay. So we need both A and B. So if we took any of the side switch, first step is to ground this one and also this. You can choose any of this hole. Okay. Then terminal 1 to ground, red, terminal of the other switch also. So both the switches are now okay. And you can take the output of the first switch from first terminal itself. This is more desirable pattern, and connect to this. You can see that first input is on the first pin out of the IC. So I connected from here to here. So
Yes.
if we turn on this switch, means current will flow into this input. If we turn off the switch, means 0 volt will be present at this pin out. Okay.
Yeah, okay.
It
Yeah,
is
got
like
it.
a common convention to connect like this. People like connect like this.
Okay.
This switch,
Common
this is a
convention.
three-way switch. It should be followed like this way only. If two-way means nothing is there, just two terminals only, it will be much helpful. But it is a three-way switch, so it
Okay,
should
yeah.
be connected in this way only.
Yeah.
So
Got it.
if I turn on this switch, here voltage will be 1 as of the logic talking. Here it will be 1. If we turn off that A switch, it will be 0 here. I hope everyone understood this. Okay.
Yeah, got it. Yeah.
So our first aim is completed. Here this side is completed. Input 1 is completed. Next we are going to input 2, that is B. So we can take the connection from first terminal, any of this terminal, and connect it to 2. Okay. So 2 is completed. And I forgot one thing. When we take an IC, first job is to ground. That I forgot. Sorry. This should be completed. Positive. Okay. Sorry. So okay, everything is completed. And next is the output of this A and B. That is A dot B 3. So we can take 3 and connect straight away into the bulb. So when we turn on the simulation, we can see that when we turn on A, sorry, when we okay, yeah, sorry, what's there happen means yeah, you can see that in the logic of AND, for getting an output of 1, so both A and B should be 1. Okay. So
Yeah.
we need to on both the switches.
Yes.
What here happens means when we turn, oh,
Turn on one.
there is some problem. Is 1 minute, guys. Let me move this. Okay. When I turn on this switch and this switch,
Elias, maybe can you remove the comment? Maybe it will.
Yeah, for a while I will do. It's disturbing my job. Yeah. Start simulation. Okay. Then first switch we can turn on. Second switch also turn on. Then you can see that our IC is broke and there is given a high current is flowing through the pin 1. You can see that. Okay. Device broke because of the current. In order to avoid this, we can easily correct this by putting a resistor in series with our bulb.
Okay.
Okay.
Yeah.
So we can rotate this resistor if need by clicking, selecting this resistor and click here this icon.
First so it's enough to connect the resistor at the third input, right? The third terminal, right? Is it
yeah.
or?
You can see that third input of the first AND gate. Only one gate AND gate we are using. Among four, only one we are using.
Okay. Yeah.
So remember that in order to connect this through a resistor, so that we can reduce the current flowing through our IC.
Okay.
Let this resistor be 1K or ask you like 3K, no problem. 3K is not available.
But Elias, the one doubt I would like to ask is, when you turned on the first switch, nothing happened. But when you did it for the two switches, it broke. But even after switching one switch, there would be high current flowing through terminal 1, right?
Yeah, but the circuit is not completed.
Okay, yeah. Oh, yes, yeah.
Yeah. So one more time, we are starting the simulation.
And the goal is to protect the IC. So so to make sure that the high current doesn't flow through the IC, we connect a resistor before the current reaches the IC. That's the thing. The goal is to protect the IC.
The advantage of the simulation means we can predict what is going to happen if we do this practically. Otherwise, there will be a high heat inside this IC and IC will burn within our hand itself. Okay. So simulation software we can help. We can easily see that high current earlier we can predict. That's the advantage.
Different scenarios we can test. That's
yeah, completely that. Okay. So if we turn on this A and B, the bulb is on. Now there is no problem with this circuit when we connected a resistor in series. Okay.
Oh yeah.
So,
now it's
I am testing all the case. First A is on and B is off. So 1 0 1 and 0, the output is 0. So you can switch all the cases and test. Okay. This is basically a basic AND IC.
Yeah. Okay.
Okay.
Got it. Yeah.
Okay. And as all the ICs has the 14 pins,
we can test similarly. Yeah. We can test using similar.
Just delete techniques. This IC and OR gate. Where is the OR gate?
Yeah, quad OR on the right. Yeah.
Quad OR and place as the same like. Okay. Sorry. Okay. And the start simulation. You can see that if A is on. Sorry.
1 0.
Oh, wait a second. Yeah. Where is our OR? 1 or 2.
The last one.
The last one.
Last one, ALIAS.
Sorry, something problem I think happened.
No, the last slide.
Fifth one. I think he's getting some software error.
Oh, okay. Yeah.
Sorry, something happened. Yeah. Yeah. Something happened.
Elias, we had doubt in the chat section. Can you check that?
Okay. Wait a second, I will come back.
Okay, Ashwin, I think I can answer you with that because in AND gate the circuit is only completed when 1 and 1 comes out, right? If the input is 1 and 1, then the AND gate results in a 1. Okay, that's only when the circuit is completed. So if one of the switches is on, then that means only one of the terminal is giving a 1 as input and the other terminal will be giving 0 as input. So 1 and 0 would mean the output to be through the AND gate, the output would be 0. So even if you have a resistor there or you don't have a resistor there, the circuit is not complete because 0 output, the output is going to be 0. That's going to be that's going to be into the bulb.
Let me add one thing. You can connect a resistor anywhere. You can connect.
Yeah, anywhere in the circuit you can connect a resistor.
Yeah,
so that
from starting from the here you can connect the resistor, or in that circuit anywhere in series you can connect, not in parallel. In series, any of the side you can connect that resistor. It is better to connect in the terminal of the bulb side itself. Okay. So
the current before entering into the IC should be regulated, right? Then only the IC
no,
could be.
how does current flow? The current flows when the circuit is complete, right? So first of all, we check the so adding a resistor anywhere in series that basically decreases the current wherever we place it.
what we can try. Yeah, before entering the IC.
Okay,
No
okay.
problem.
Huh.
Okay.
Guys, if you have any doubt, you can speak up. Okay, this is completely informal.
Yeah, you can try as Ashwin
Guys,
told. You can try all these possibilities. Okay.
Come on, Jose. Yeah,
if
you can speak.
possible, if possible, can you explain the working of that push button, that switch?
Yeah, the
Push
working
switch.
of the switch. Can you get to explain that thing?
Working this of
Yeah, the slide switch. Yeah.
Slide switch.
Slide switch.
Yeah. When we take in a slide switch, the terminal that I think connections is okay. As Ashwin told, we can add a resistor on the first terminal so that before entering to the IC, we can add a resistor here. No problem for that also. Yeah. So okay, I will come back to that switch. Okay. If we turn on this switch, means the output of this will be connected to this power supply, so that current will come through here.
But Elias, he was asking how the switch works. Like, can you complete the circuit using the switch?
Yeah, that's the yeah.
Can we try it with the normal circuit with a single bulb?
Easier circuit. Yeah,
And that way.
don't go with the ICs. Just a simple circuit.
So available only here, push buttons and side switch only available. Two-way.
No, he was asking by explaining.
Like just open a new circuit. Just open a new circuit and
going with a simpler circuit.
do that.
Okay. Yeah. So first, please consider this switch only. Leave with that. Leave the other switch. So your first job is to ground this switch and the terminal. So better to connect the resistor in front of that switch, as Ashwin told. Okay, that's better, I think. Yeah. Then we take the next step is to take the output from the terminal 1 and connect to this bulb and turn on the simulation. So if we turn on this switch, our bulb is on. Turn off. Okay.
What this switch basically does is it gives a pathway for two horizontal slots. Okay, it gives a path for the current for the two horizontal slots to flow freely.
If we turn on this switch, means it is connected. This positive is connected to this positive. Through this connection is completed. This connection.
So Elias, can you draw some lines to show the path of the current that is flowing?
Of course.
Something like that.
Well, you can look that here. It is come from here, and comes from here, and comes from here, and enter into our switch. So here. So you can also ask that if there is what's the need of switch. It is already connected to here. That's your doubt, I think. Yeah.
Yeah, that's what he gets it out of.
If we turn off this switch, means it will conduct these two conduct. So what is the easier way to current to flow? Is this to complete? Is this way or this way? Current always flows through lowest resistance only. So the now when the switch is off, this two is conducting now. This two side.
Okay, Elias, can you do one thing for the bulb part? Can you take the black terminal? Can you cut it off for the bulb? The bulb.
Yeah.
Can you cut it off?
Why we need three? Why we have
it's all right.
three
Now,
terminals?
now you can. I think you take. Okay, so he's asking why do we need three terminals? Like,
why
Jose, can you?
Why we have three terminals?
Oh, okay.
are used.
That's a three-way
I don't
switch.
know
Like,
nothing about that.
okay, yeah.
No, no, no.
Yeah,
It
me
is
too.
not a three-way. It is a two-way switch. Okay.
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 Yeah.
So a two-way switch means basically you can see in our home, etc. There will be two parallel switches to control a single circuit. So if you turn on any of the switch, our device will be on. Okay. So it has three terminals. If you take inside a look of the switches in your home, or I will search that.
Alias,
Yeah.
like,
You can see
can we
here.
wrap up within 30 minutes, like, so that they get time to eat the food and then
Okay.
join for the next slide? Okay.
Or
Just wrap up.
we can pause this and continue.
It's all right. Let's wrap up this within 30 minutes. I think we don't have much more to discuss, right? Within the ICs would do the thing. I think yes.
So okay. Okay, you can see that this is the switch we are using in our home. This is the normal two-way switch. You can see that there is three terminals is there. You can see it is the common terminal. Sorry, it's the common terminal, and there is two lines here. This is the switch we are using in our home. Two-way switch, not one-way switch. Okay.
Okay. Okay.
You can Google and look many other possibilities also. This is the
I
connection
will
we are
check my
making in our home. Okay.
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 So
Josh, what happens is common is connected, and on one terminal there is no connection. That is the off position, and on one connection and on the other terminal connection will be there, and that will be the on position. And when the switch is on, the connection will be complete, and when the switch is off, the connection will not be complete because on the other terminal there is no current. Like that's how it works.
okay.
Yeah. Okay. It's basically a two-way switch, right?
It's basically a two-way switch.
Two-way.
Yes.
Yeah.
Okay. So we can construct here. This is the problem we will be dealing with. And here there is a Boolean expression A plus B and gate B naught plus C. So we need to implement this in the Tinkercad. Okay. This is schematic and this is the truth table in order to test. So first we need to draw the schematic, and we can see that there is two OR gate, one NOT gate, and one AND gate. So, and there is how much input is there? A, B, C. Three inputs are there. So we need three switches.
Elias, one more doubt. So they are asking if we will be able to use another switch, like an on and off position, just an on and off position.
Yeah,
No,
that
we
switch is
don't need.
not available in the Tinkercad. That is the problem.
Oh, okay.
Yeah, that
What about push button? Push button. What does
push
it do?
button means we can only hear these two terminals you can use.
Oh, that's even more complicated. Yeah.
No,
I don't
not
need-
complicated. What is the problem means we need to press this switch for conduction. We can't leave this. We always need to press this. Just you can see many other.
It will only be lit when we push the. As soon as we leave the mouse from there, it will be off.
Oh, so we should keep pushing for the keep pushing it till we want the circuit to be complete.
Yeah.
But ALIAS, it's a push button, right? So
yeah, push button, button switch. That is more.
we don't have to press it continuously. Sorry.
Yeah.
It's a push
we
button,
need
right?
to press it continuously for the
okay.
conduction. That is more. We can't leave it. That's the problem.
Yeah.
So basically, we choose three switches. We are constructing this schematic. Okay. So ABC is there, and this will be the problem we are dealing with our sections. So we can ground this. I'll be moving so fast. Okay. A resistor. We can ground. Okay. Please select. Change the color. Sorry. Okay. Then we can see that there is two OR gate, one and one NOT. So we need to fetch that IC from here. So one NOT gate we needed, and one AND gate we need, and two OR gate. So you can see that we not to select, no need to select two OR gates. One not need to select this two OR gate, because our single IC has 4 OR gate inside. So we can make use of that. Okay.
Okay. Yeah. Yeah.
So please look that it is our inverter section.
So I think as Ashwin said, it's always feasible to connect the resistor at the beginning of the circuit itself, right? So we can control the current to all of the circuits in a correct manner. Yeah.
Yeah, that as you like that, no problem. Anyway, what your desire you can do. Okay. So what's the job means? Okay. So first we are going to implement this. So first we need an OR gate. We will be dealing with OR gate. This OR gate. So first the input first input is A, single A. So please comment this, otherwise it will be messy. Okay. While commenting, just place it above so that earlier possibility will be avoided. Okay. It will be C. So first what is our first aim? Connect this A to first OR gate. So 3 2 is our OR gate. As you can see, OR gate here input first OR gate this 1 2 3. Okay, we need to make use of 2 OR gates. So 1 2 3 4 5 6. So first this OR gate, that is 1 2 is the inputs. So 1 to here, that is A to the first input terminal, and next is the schematic. B is connected to the next terminal. So B first, always we take connections from the first terminal. Please remember, okay? Next terminal, and the output of this output A plus B to the first terminal of the AND gate. So this is our AND gate. This is the output terminal, and we can choose this. Our connection is made to the input terminal of this output to the input of this OR gate output to the input of AND gate. So
Yes.
this one is completed.
Yeah. Okay.
Yeah. Next will be starting from here. So B to the B complement first. So take connections from B to the B complement. So I will be choosing different color. Okay, because it will be green color. So starting connections from B to this is the OR gate. It's a NOT gate. So input of NOT. Sorry. Input of NOT, and you can see that NOT gate only one input and one output. So taking the output from
Terminal
to other OR gate.
Yeah. Okay.
So this is the first OR gate section all completed. Next we will be starting from here, input to A. Okay.
Yeah, clear.
That is completed. Then C to other. We can select underneath here and connected input to B. Okay.
Yeah.
Then taking the output that is to be connected to the first input terminal of the AND gate. This gate here, this gate. Okay.
Yeah. Yeah.
So here, it is messy. Okay, please be careful. And taking the output from here, this AND gate output to the bulb, and starting the simulation. So we can see that only the possibilities, everything is on, or these two possibilities, these 3 4. So we can turn on A, okay, turn on B, and turn on C. Sorry, we also need one more resistor for that bulb case.
Oh, okay, okay. So we can we increase the resistance just?
Yeah, no problem. We can increase. There is no problem at all.
Okay.
So that our bulb will dim. Okay.
Dim. Yeah.
Okay. Start the simulation. Again, there is a problem. Let me check.
I think because there are 3. I think you need 3 resistors to simulate that, maybe. Or I think it would be preferable to just increase the resistance.
Oh, sorry, guys. IC is not grounded or sorry.
Oh, okay. That's an important thing. Okay.
I always forgot that. Sorry. The basic as we move on, We'll forget. Okay.
So what grounding actually does to the IC? Does it give a power supply to the IC? That's what it does.
Yeah. That section, I think it is more complicated. We can leave that.
Okay.
Okay, you can see that bulb is blown. Okay, so A is on, B is on, C is on.
Yeah.
You can check all these possibilities. First, A, let it be 0. A 0, B 0, and C 0. Bulb is off. Next possibility, output is 0. A is on, C is on. Okay, bulb is again 0. Next, B only on, and C off. Bulb is 0. Next one, B and C on. So on. Sorry. Okay. B is on, C is on. So bulb is on. Okay. Next possibilities, B, C off. The bulb is again on. You can test all these possibilities. So we can. This is how we implement that this Boolean or function into the breadboard. Is there any other doubt?
Alias, there was one doubt that Austin raised. Why do we have to ground the resistor if outer rails are in the same connection?
That's I doubt. I think we not need to know more about IC. I think.
Okay.
We just need to implement that.
Just implementation part only matters, I guess.
Yeah.
No, can I speak?
Yeah.
Yes, of course.
Yeah, I asked about the resistors beneath the switches. I think that is not related with the ICs.
Which one?
The one in the bottom, the 3 in the bottom.
This
Two
one.
of them are those.
This is not resistor. This is a condition.
No, not that one. The one left to that.
The resistor. The resistor one. Yeah.
This one, right?
Why is it grounded to the next?
It is not grounded. It is connected to the positive terminal only. As Ashwin told, you can avoid this also. No problem. Okay, that you mean. Okay, you can avoid this. No problem for adding resistor. There is no problem. Okay. We can. Is there? If we add more resistor, means our bulb will be more dim. That is the only problem here.
No, he was not asking about. Why? He was just asking why you gave another wire on there, like orange wire. You see that orange wire over there?
This one.
Yeah.
Yeah, this is.
Was that?
Okay. Here we can connect straight away to the positive. So that's why I connected straight away.
Oh, okay. It's not possible to do that. Okay.
Yes, here there is no hole here. We can expand this connection. That's
okay. There was no hole there. Okay, I didn't see that. Okay.
In the similar way, you can try many other Boolean expressions. It is just one example only. You can try OR gate, NAND gate, and as you can expand your ideas.
But we got the basics right. I think this was really helpful because I was starting from scratch and I got this. It's very helpful.
You can choose the diode. You can choose the transistor. You can try variety of ways. Okay.
Guys, was it helpful? Like, do you have any more questions, or would you like to know more about this thing so that we can wrap up if you have nothing?
Yeah.
And
any kind of resistor values for this circuit?
Yeah, you can use any of the resistor. As here it is 1K, you can use 100K.
Okay, Alias, can you change?
Depending on the value of the resistor, the light, the brightness of the light will be dim. Like the value of the current flowing through the bulb will decrease.
Yeah.
Okay, so but can you show how to change the resistance? Can you show how do we
select this resistor and choose the value from here?
Okay, that's all.
Yeah, that's very easy, I think.
That's all.
I don't go with the 1000 etc. Okay. So current will not flow through that. Okay.
Oh yeah.
So okay. 1K is enough. As available in the market, 1K and 100K is the available, most availably, and 220 is available. Okay, that way.
Okay, then one more thing is that WebEx-ന്റെ കാര്യം ഒന്ന് ചെറിയൊരു പ്രോബ്ലം ആളുകൾക്ക് വരാറുണ്ട്. അതുവല്ല നിങ്ങൾക്ക് അറിയോ?
എന്താടാ പറയണ്ടേ?
ഇപ്പൊ ഒരു എങ്ങനെയാ ഡൗൺലോഡ് ചെയ്യുന്നതെന്ന് കാണിച്ചു കൊടുക്കുക. WebEx അവരെ തുറക്കുമ്പോൾ എന്തുവാ കാണുന്നതെന്ന് ഒന്ന് കാണിച്ചു കൊടുക്കാൻ പറ്റുമോ?
ഞാൻ ടെലിഗ്രാമിലാണ് അതിന്റെ ഇൻസ്റ്റാളേഷന്റെ പാക്കേജ് ഇട്ടിട്ടുണ്ട്. അവിടെ നിന്ന് നേരെ ഇൻസ്റ്റാൾ ചെയ്ത ഞാനിപ്പോ കാണിച്ചു തരാം. ഞാനൊന്ന് ഷെയർ ചെയ്യാം.
share it.
Dan.
Yes, please address.
Yeah, I had a doubt about the poll